Bismillahirrahmanirrahim. Assalamu alaikum dear students. Hope you all will be doing well. Welcome to Forward Public School e-learning class 10th subject chemistry chapter number 9 chemical equilibrium. Today we will discuss the 8th part of this chapter, part A, that is numericals, and I am your teacher Mehreen Zafar. Let's begin the topic. We will study first the numerical number 9.3 and this numerical is present on book page number 14. First we will know the statement. The statement of numerical is in the equilibrium mixture the concentration of hydrogen and iodine is 0.04 mole per decimeter cube each while that of hydrogen iodide is 0.08 mole per decimeter cube. Find the value of the Kc for the given reaction. I have highlighted the concentration along with the species in order to better understand the numerical. Now we will start the solution of the numerical. First of all, we will write the balanced chemical equation, that is hydrogen plus iodine. They will give you hydrogen iodide. Now next step is given data. In given data, we will write the concentration of each species which is given in the statement, that is hydrogen, iodine, and we have hydrogen iodide. The values is written in front of each concentration. Next step is required. We are required to calculate the equilibrium constant, that is Kc, for this chemical reaction, for which we have the formula, that is Kc is equal to the ratio of the product to the ratio of the concentration of reactants. So we will divide concentration of product over concentration of reactants in the next step. Here we have the solution. After putting values in the formula, we get Kc equals to 0.08 mole per decimeter cube whole square divided over 0.04 mole per decimeter cube into 0.04 mole per decimeter cube. Students, pay attention towards the square, which means that we have to multiply this value double. After multiplication, we get the situation like this. In this case, we have mole per decimeter cube whole square in the numerator and we have mole per decimeter cube in the denominator, which means that they will cancel out with each other. As a result, we will only be left with the numbers. Now we can easily multiply and divide the numbers to get the answer. So Kc equals to 6.4 into 10 power minus 3 divided over 1.6 into 10 power minus 3. Now here we can see that we have minus 3 in the numerator, will cancel with minus 3 of the denominator, and we will, after division, we will get the answer, that is Kc equals to 4. Now next is result. In result section we will write that equilibrium constant is equal to 4. Dear students, do practice of example 9.4 from your book on page 14 in your rough notebooks in order to better understand the numerical concept. Next we have practice problem number 9.4 and this practice problem is present on page 14 of your book. Let's have the statement. An equilibrium mixture of nitrogen, oxygen and nitric oxide gases at 1500 Kelvin is determined to consist of 6.4 into 10 power minus 3 mole per decimeter cube of nitrogen, 1.7 into 10 power minus 3 mole per decimeter cube of oxygen and 1.1 into 10 power minus 5 mole per decimeter cube of nitric oxide. What is the equilibrium constant for the system at this temperature? Again, we have given different concentration and we have to find the value of Kc. Let's start the solution. First we will write the balanced chemical equation, that is nitrogen plus oxygen will give you the nitric oxide. Second step, that is given data. We have the concentration of nitrogen, concentration of oxygen and concentration of nitric oxide. We can get it from the statement as it is already mentioned there. Next we have required. What we are going to calculate, that is Kc equals to question mark. For calculation we will use the formula, that is Kc equals to the ratio of the product to the concentration of reactants. Now next step is solution. Putting values in the formula, we get the situation like this. In this case, we have 1.1 into 10 power minus 5 mole per decimeter cube whole square divided over 6.4 into 10 power minus 3 mole per decimeter cube into 1.7 into 10 power minus 3 mole per decimeter cube. Dear student, in order to simplify it, we can simply separate the number and the units. You can clearly see that mole per decimeter cube whole square in the numerator will be get cancelled with the mole per decimeter cube in the denominator, and now we can easily multiply and divide the numbers. So Kc is equal to 1.1 into 10 power minus 5 divided over 10.88 into 10 power minus 6. Now the question is, from where does it comes? When we multiply 6.4 with 1.7, we get the answer 10.88. And 10 power minus 3 multiply with 10 power minus 3, you will get the answer 10 power minus 6. Now after division, we will get the answer 0.1011 into 10 power minus 5 into 10 power minus 6. Kc is equal to 0.1011 into 10 power plus 1. Plus 1 means that we will shift the decimal one number towards the left, and in order to get the answer, that is 1.011, which is the value of the Kc. Result. In result, we will mention that equilibrium constant is equal to 1.011. This is the end of topic 8, part A. Hope you have understood the solution of the numericals. We will be back with the part B in the next lecture. Thank you. Stay home, stay safe.